The life cycle of stars is a complex and fascinating process that spans millions to billions of years, depending on the star's mass. This cycle begins in vast, cold clouds of gas and dust called nebulae, which are found throughout galaxies. Within these nebulae, regions of higher density begin to collapse under their own gravitational pull. As the gas collapses, it heats up and forms a protostar, an early stage in a star's life. The protostar continues to gather mass from the surrounding cloud, and its temperature and pressure increase. Eventually, when the core temperature becomes sufficiently high, nuclear fusion reactions ignite, fusing hydrogen atoms into helium. This process releases immense amounts of energy, which causes the protostar to shine, marking its transition into a main sequence star. During the main sequence phase, a star spends most of its life in a stable state, where the outward pressure from nuclear fusion in its core balances the inward pull of gravity. The duration of this phase depends on the star's mass. Massive stars consume their hydrogen fuel much more rapidly and have shorter lifespans, sometimes only a few million years, while smaller stars, like our Sun, can remain in the main sequence for several billion years. Over time, as the star exhausts the hydrogen in its core, the balance between gravity and pressure is disrupted, and the core begins to contract. The outer layers expand and cool, causing the star to evolve into a red giant or, for more massive stars, a red supergiant. During this phase, helium fusion begins in the core, producing heavier elements such as carbon and oxygen. For a star like the Sun, this expansion eventually leads to the shedding of its outer layers, forming a glowing shell of gas known as a planetary nebula. The core that remains cools and contracts into a white dwarf, a dense, hot remnant about the size of Earth, which gradually fades over billions of years as it radiates away its residual heat. In contrast, the life cycle of a more massive star follows a more dramatic path. After expanding into a red supergiant, it undergoes a series of increasingly intense nuclear fusion reactions, creating elements up to iron in its core. Once iron is formed, no further energy can be extracted from fusion, causing the core to collapse rapidly under its own gravity. This catastrophic collapse triggers a supernova explosion, releasing an enormous amount of energy and scattering the star's outer layers into space. The core that remains may become a neutron star, an incredibly dense object composed primarily of neutrons, or, if the original star was sufficiently massive, it could collapse further into a black hole, an object with gravity so strong that not even light can escape. Throughout these processes, stars play a crucial role in the cosmic cycle of matter, creating and distributing the elements that make up planets, life, and everything around us. As stars end their lives, the elements they have formed are returned to the interstellar medium, enriching it with the building blocks for new stars, planets, and eventually, the potential for new life. Thus, the life cycle of stars is a continuous and dynamic process that drives the evolution of the universe, shaping its structure and fostering the conditions necessary for the emergence of complexity and life.